Hey everyone, this is Natalie from Engineering 1331 Group 19, including Jason and Haiti. This video is to introduce you all about our current group project. My team's topic is about a chemical processes problem, which is ammonia production, especially the HAPA process. This engineering problem is related to many other chemical manufacturers that involve gas recycle, such as methanol and formaldehyde production because of its usefulness and saving raw materials. The first thing I wanted to talk about in the problem is the problem statement. Nitrogen and hydrogen and inert gas are streamed to produce ammonia. After condensed selectively, the ammonia, a part of the remain, is purged over here on the right, and then the rest comes back to the recycle and come back to the fresh feed. The problem you have to solve is you have to solve a problem algebraically for the compositions of the gases in each stream and calculate the NP, the mole of the ammonia, and NR, the mole of the gases that comes to the reactor, and the FOV is the conversion factor of nitrogen overall. And then you have to state the relationship between the NP and three input variables. Three input variables are XI0, FSP over here, and then the YP, YParch. And then you have to calculating the cost of the cooling system for the ammonia. The governing equations, they are general balance equation: input plus generation equals to output plus consumption plus accumulation. This is for the inert gas, so you don't care about generation and consumption, and also you don't care about the accumulation either, because those make no sense for this case at least. And you have a thermodynamic equation. The heat is equal to the mole and its change in temperature times the capacity heat, the specific heat capacity. And then you have the latent heat equation. It is the Q equal to mole times latent heat. Basically, in this case, I use joule over mole as a unit, so it's going to be more easy. And then I want to talk about the algorithm. Okay, we need to deal with the at first, when we start, this is for the flowchart of the whole thing, so I'm not gonna talk about these three steps at first, because we need to solve the problem by hand. I'm gonna set out the variables as they are appear in the process chart, like over here. This is how you set up this process, the problem, and then the all variables, and you calculate, and you have these three. You calculate all of them by these, and then you call n1, n1, and n2, and you calculate everything by these one. So using the mass balance equation I just showed you, you can have this. And then you can solve for purging. Purging is the mole comes inside and mole comes outside. This is for the purging problem. So for the purge and then fresh feed, the number of things inside, they're the same, so you can come up with this. Therefore, you have n2, plug into over here, you come up with n1, and then you solve everything. I have the answer for you over here, just in case you want to check. Over here, the result. And then we come back. Okay, and then you call a function that takes three inputs, these things, to calculate these. So I'm gonna show you right now after pulling the MATLAB. Looks like I have the MATLAB pulled up, and I can tell you that this code is to solve, the first task is solving the composition of the gases algebraically. So I use this function, use the solve function. I say what is the variables in this case, and then I tell them solve this for me. So I give it an equation. It's simple, you can do it by yourself, but if I run it, This is what you end up with. So basically you have the answer over here. And if I compress this and I put it up, this is also the equation, the solving for n1. And if you're lazy, you can use this. And then after you have n1 and n2, you can calculate all of these, and then you can compress all of them, and then you can copy this, so you can calculate all of these. These are the answer I got it over here. These are the answer I got from the test case, from the result chart I just showed you. But these can be solved by this one too, so it's good. And then I have to talk about the algorithm. This is you have to ask the input and then check if it's good or not from 0 to 1, I'm sorry. And if it's wrong, tell it's wrong, and then ask again. And if it's yes, keep doing stuff. So in this case, I'm going to run it for you. This is the GUI that it basically is just a window that it looks like an app that have the interface, like the user interfacing interaction. So you have, after I input this, I'm not gonna put these again. I just gonna click this transfer data input, and then I have just exactly what I just got over here, and then I process the data. This is the task 2. It tells you that to keep the three variables varies from 0 to 1, and change and make a graph that has a relationship between these three, and then it calculates for you NR and P and FOV. Basically, it is a kind of a function, and it is I call it messed up because when I made it, I messed it up a lot. So yeah, I didn't change it. And then if you say, oh yeah, I messed up, I screwed up these things, I screwed up the input variable, so you can put it again, like 1.15 or 0.9 or 0.6. You process the data, and then you have a new result. Later you figure out, oh yeah, I got the right thing, I shouldn't change it. So just data input is what the original you put in over here. So process the data, you're good, you have the same result, and then you close it. Look at this. The task 3, it asks you what is the relationship. So I say, according to the graph, NP is decreasing while YP increases, or therefore the purchasing fraction YP must be minimized. Basically, it's telling you that the relationship between these, so the graphs, you can see the graph from graphs, and then it tells you over here is the answer. And then later you have the explanation of relationship between the three variables. It is a question, so I try to use the F-pin to show in the command window just to make sure I didn't miss anything. And then you calculate the theoretical maximum of ammonia amount produced is 0.4950 mole. I use this. Basically, I create a range of everything, like 0.1 to 0.99, and I output it, and I use the same thing, and I give it from 1 to whatever. Like I check every single thing, just like in my algorithm. I calculate, okay, I calculate this, I calculate this, I calculate this, and oh, I didn't say this. Observe the graphs and calculate the average slope. Each graph you can see like goes down, go up if the slope is positive. Increasing function. It means you have to be maximized because the thing increases, so the more increases, basically you have to maximize it, and the other side otherwise minimize. And then you set a arbitrary value of NP is 0, like the maximized one, the maximum. And then you let all three variables run from 1 to 0 to 1. So, and calculate the new value of NP. So if this value, the new value in every time, is greater than this one, if yes, boom, and then go back. And then you finish task 3. Task 4 is you have to calculate the cost of the thing of the coding system. So you have to call a function. This is my function. The cost function is called cost calc. It means cost calculation. It has 4 variables. As the question asks, like the n is not 1 anymore. The fresh feed input mode is not 1 anymore. So basically I have to use the input to deal with it. And so assign the ammonia, and this the whole thing. Basically it's just the basic math, so you don't have to care about it. But I'm glad that you can check my algorithm to know what's going on as a user, and as a user to input these things. And then you check the input false if it's 0 to 1. If it's yes, move on. If it's no, come back. So you can do this, and then the specific heat table, basically I already put it in my function. So yeah, and convert the ammonia heat. Basically it's over here. Basically everything is over here. You calculate the cost, you calculate the energy, and then you calculate the energy absorbed it, and the energy that you also absorbed it by the system, because they are all exothermic processes. So you need something like endo, something like absorb the heat. So basically that is your system. And then you plus all these together. This one I put negative sign over here. So basically in this side, if you want it to be positive, I put another negative sign. It's just that how you deal with the problem by yourself, but basically the answers should be the same. And you calculate, you convert the energy, and you calculate the cost. So this is what you have. So you have everything, and then if you ask, you can ask the user, hey, you want to repeat this? Yes, come back. If no, you're done. So I'm gonna run this for you so you can see what's going on. Okay, 0.5, I mean 1.5, 0.1, 5, 0.34, 0.1. This is the vector, and here you go, this thing. And if you want to say yes, yes, and I have to answer again. So 2, 0.9, 0.9, 0.9, I don't care. And it's a new cost, and you want to repeat it, I'll say no, and then you're done. There's one problem with this code is that it's not really flexible when you change the number of the mole of the fresh feed, which is 1 at first. If they change it to 1.5, I mean everything's gonna get to 1/2. But if you make your own code, I suggest you to write n0 equal to 1, and then you calculate everything by n0. So just in case the problem asks you, hey, it's not, I mean your boss asks you, hey, it's not 1 anymore, it's gonna be like 2 or 3, you can still change it. And then that is the problem of this code. but I also just suggest you the way to be more flexible in the way you do it. And one of the things I really like about this code is that you can solve a problem by this algebraically in symbols. I really like this in MATLAB. Sometimes I'm very lazy, so I just make it to do everything for me. So I solve N2 by doing this, and then I have the thing, and I just copy and paste, and basically I just have it, and then copy over here. This very good for MATLAB, and then I really like the GUI thing that is built in MATLAB, just in case like I change my mind in the way I do stuff. Like I don't have to like close the window and then terminate the program and run it again. I don't want to do that. I just transfer data input and then process the data. It has everything for me like put up, and then if I change my mind, 3, 9, and 1 is the same thing. So basically you have the new results, you have the new thing, and if you change your mind again, you think you're right, transfer data, input, process data, you have the same thing. So it's really good, and basically MATLAB is really a good tool when and then and yeah, that's it. Thank you for watching. I wish you good luck for your group project and for your upcoming exam. Thank you.